Today's topic is about dividing polynomials. So when we talk about dividing polynomials, talking about mostly just kind of factoring out terms using the quotient power of exponents, the quotient rule of exponents to divide, and so that's kind of what we're working with. Now in this lesson in particular, we're only talking about dividing polynomials with a monomial. Okay, we're not talking about long division with multiple polynomials, only polynomial divided by a monomial. Okay, so let's go to the first example going here. We're going to do 8a squared plus 20a over 4a. Okay, so there's two ways you can really work on this, and I'll show you both examples here of how this works out. So the first way, we're going to look at our 8a squared and our 4a. So we're only going to look at these two here, and we're going to divide these here. Okay, so whenever we start dividing here, we always look at our big numbers first, right? Our bases, we have 8 and we have 4, right? So if we start there and look at 8 and 4, we can divide 8 divided by 4, and that gives us 2. Okay. Now looking at our letters and exponents, we can use the quotient rule here, and every time we divide letters and exponents, we just, if it's the same base, it's the same letter there, which we do, it's a, we can just subtract the exponents, and so we have 2 up here, we have 1 down here, 2 minus 1 gives us this a by itself. Okay, and of course the way, as I've said in the past, I like to look at this when you're trying to figure this out, which side has more, in terms of the division bar here, has more a's, the top side or the bottom side. What the top side does, it has 2 a's, the bottom one has 1 a, so which one has more? The top by how many? 2 minus 1, 1. Okay. So now that's our first one is done. We can go ahead, because it's a plus here, it's a plus here. We know it's going to be a plus here. We look at our second part here, okay? So once again, look at our big numbers here. We have 20 and 4. So if we do 20 divided by 4, that gives us 5. And then now here, they each have an a, right? So because they each have an a, they cancel out. We don't need to add anything more to this. The bottom part is canceled out completely. And this is our final answer, 2a plus 5. Okay. Now another way to do this, if you want, is you can split this problem up into two and solve it out. And you might find this easier to understand and easier to comprehend. Okay. So we can go 8a squared over 4a, right, and then plus 20a over 4a, right? So basically I just took this, kind of split it up, right, into this here, and this is the same thing as what we have here. And you can just solve it, this part and then this part as it is. And then maybe a little bit easier way to see it, to comprehend it, okay? So then once again, just to kind of go through it real quick, if you're doing this like this, 8 divided by 4 gives us 2. Our a's here, which one has more top or bottom? The top. By how many? 1, so 1a here, and then plus 20 divided by 4 is 5. Our a's cancel out, and we're still left with 2a plus 5. So another way you can do this here, as you get into longer polynomials and starting the trinomials and everything, maybe this would be the better way to do it, and it probably will be, and I'll show you why. I'll show you why in the next one here. Okay. Alright, so to do another example, let's do 4x to the third plus 1 over 2x, okay? So I'm going to go ahead, I'm going to split this up. I'm going to split this up as it is, and we're going to go 4x to the third over 2x, and then plus 1 over 2x. So once again, I just split the top part and the bottom part up into two things. This is the same problem as this, okay? I just split it up, gave each of these their own thing, okay? So let's go ahead and let's solve it as it is, right? So look at this part here. We have 4 and 2. So we have 4 divided by 2. That gives us 2. Look at our x's. We have x3 on top and x on the bottom. So once again, I ask myself, which side has more? The top side or the bottom side? Top side has more, but how many? 3 minus 1 gives us 2. So we're going to have 2 x's here, so x squared. Okay, so this one's done. Now looking at this side here, if you look, this 1 over 2x, 1 divided by 2x, there's nothing we can do with it, really. We can't cancel this out. There's no x's anywhere. So we're just going to leave this just as it is, like that. And that's going to be our answer. Okay, so that's our final answer is this here. 2x squared plus 1 over 2x, okay? Now, some people may be inclined to do this as your answer, to combine it and do 2x squared plus 1 over 2x. This is not true. This is not the same as this, okay? This is not equal to the same thing, because this 2x, if you write it this way, you're implying that this 2x goes to both this and the 1. Well, it only goes to the 1, remember? When we did this up here, we canceled out that 2x. It's gone. We divided to get this. That's why it has to be like this and not this. Okay, so don't put them back together if you do it this way. And to show you kind of how it works out, keeping them together, okay? If we keep them together like as such, so we keep it as 4x to the third plus 1 over 2x. Once again, 4 divided by 2 is 2. X to the third minus, or divided by x would be x squared. And then this side we have 1 over 2x, now because, once again, we have plus and then 1 over 2x. So that's why I said doing it this way, you can kind of break it up and see this side first and then this side, because if one side cancels out that denominator, and the other one has both the numerator and denominator, you can keep that as it is, and not have to worry about here where you're splitting it up and kind of making sure you keep this as a fraction, okay? So this is how we're going to do it right here, okay? Just because going forward, it's just kind of easier to understand, okay? All right, so another example going. Let's go 12x to the third minus 6x squared plus 15, all divided by 6x, okay? So I'm going to go ahead, I'm going to split this up into 3 different parts. Each of my top terms is going to be paired with my bottom term. So I'm going to do 12x to the third minus 6x squared plus 15, and then we're all individually going to be over 6x. Okay? And then we're going to take it one by one. Okay? So, look at our first one here. Look at our big numbers. We have 12 and 6, so we can do 12 divided by 6, and we're going to get 6. Oh, I'm sorry. 12 by 6, we're going to get 2. And then we're going to look at our x's. We have x to the third divided by x. And once again, we subtract our exponents, and that gives us x squared. Okay, nothing on the bottom. No denominator on this one here because our 6x cancels out. So go to our next one. Okay, we have a minus here, so we're going to have a minus here. Now here we have 6 divided by 6. That equals 1, so that just cancels out. We're not going to put anything here. And then our x's, we have x squared divided by x, and that's going to give us just an x by itself, because x squared divided by x, subtract the exponents, gives us x to the first, which is this x. And then we have a plus, so plus. And then 15 and 6, now we can't divide 15 and 6, we can't do 15 divided by 6, but we can reduce it, right? We can reduce 15 and 6. We can divide each number by 3. So if we do 15 divided by 3, we're going to get 5. And then if we, and then our division, if we do 6 divided by 3, we're going to get 2. Okay, so what I did, I did 15 over 6. I can reduce them by dividing each number by 3, by the same number, right? And that gives us 5 over 2. So this is the same number here as here, okay? And our x, we have one x on the bottom on the denominator here, so it's going to stay there, okay? And that's all there is to it. So really it's not that complicated. You're really just dividing or reducing, kind of how you would do it if you were just simplifying monomial. It's kind of the same thing. You're just doing it several times. Okay. So take this. Remember, break it up. Put your denominator under each term in the numerator. Okay. And then just go through, divide the big numbers, or reduce them in this case of our last term, and then just subtract the exponents as they are. Okay. For the letters. Let's do one more example here. Now, sometimes when you're solving problems that divide exponents, you're going to see it in a different way. You may see it written as such. Let's do TV squared plus 16TV plus 4B divided by 2T. Okay. Now, if you see it this way, you may think, "Oh my gosh, this is crazy." Okay. So all I have to do, if you can just rewrite it in that kind of that fraction form, right? Where we just take our tv squared plus 16tv plus 4v, right? And we're just going to put it all over 2t, because remember this is in parentheses, so it's all together. We can just take it and just put this underneath it in that fraction, and now we have it like the way we're used to, okay? So if you see it written this way, just take your last term here, put it underneath the fraction mark, boom. Now we're going to split it up. So we have tv squared over 2t plus 16tv over 2t plus 4v over 2t. Okay, so let's go through one by one. All right, first here we have no big number on top of a 2 on the bottom, so we know right away we're going to have this 2 on the bottom here. We can't, obviously, this would be a 1 here, okay, on top, but we're going to leave it blank for now. We have 2 t's here, a t on top and a t on bottom. We can cancel those out. We don't need to write them. And then we have a v squared on top and no v's on the bottom, so we're just going to keep that v squared on top of our fraction there, okay? So once again, 2 on the bottom, nothing on top to reduce or divide it by, so it's going to stay on the bottom. A t on both top and bottom, so those cancel out. Our v squared on top, no v's on the bottom, so it's going to stay on top of our fraction here, okay? Now we go to our next term. We have 16 and 2. We can divide 16 divided by 2. We'll get 8. Look at our t's. We have a t on top and a t on bottom, so we can cancel those out. And then we have a v on top by itself, nothing on the bottom, so it's going to go next to our 8 here. No denominator on this one because our 2t cancels out with both terms. And then our last one here, we have 4 and 2, so we can do 4 divided by 2 to get 2. Okay? And we have a v on top and a t on bottom, so because there's nothing to cancel out with, they're going to stay our v on top and our t on bottom. Okay? So we couldn't do anything with this with our variables here, so we go ahead and divide 4 and 2 to get 2. Okay? So that's how we're doing it. Leave it like this in this form here, and there's not much to it. Just factor out the terms and use quotient rule to figure out the exponents.